The other improvement that I put into this category is bottom-up B-tree index deletion. I'm not sure if that's actually the best name for this feature, but it's the name that we've got. What this is really about is containing index bloat. If you're not familiar with the idea of bloat, basically bloat means or refers to a situation where the tables or the indexes are getting larger even though the amount of data that is being stored has not gotten larger, or that they get larger disproportionately to the increase in how much data is being stored. So this improvement is not going to help with table bloat, but it may help with index bloat. And the specific situation in which it is expected to help is if you are repeatedly updating the same rows and you're updating columns that are indexed, but basically just that. You're repeatedly updating the same rows, and in particular, you're updating at least some columns that are indexed, because if you're not updating any indexed columns, then you don't expect to have much index bloat. But if you do meet those criteria, this adds a new opportunistic cleanup mechanism that can remove some of the bloat that might occur in that situation on the fly without needing to wait around for the next vacuum to happen. And in the right circumstances, it seems like that can make a big difference and help the size of your indexes to remain stable, whereas in previous releases, they might have grown larger over time.
So Bruce, the snapshot scalability is kind of interesting to me. As you know, one of our colleagues has been doing a lot of performance testing. What actually was the problem in sort of relatively basic terms that a front-end engineer like me can deal with?
Sure. Yeah. I mean, I really love both of these items. I mean, everyone loves new keywords and new commands, but effectively, very few people actually use the new commands. Like maybe 1% or 5% or whatever. These two items I like because they're always active. They're gonna be available to improve things, whether you know about them or not, right? They're just there. The first one is something we really struggled with for a long time, and particularly in comparison to other databases, because a lot of the commercial databases are sort of architected in a way that they can handle, thousands, tens of thousands of connections fairly efficiently. Not super great, but they handle them really well. And Postgres has always kind of been criticized for needing a connection pooler sooner, let's say, than other databases. And you see that with PG Pool, PG Bouncer, a lot of HA Proxy, a lot of poolers out there, and people are saying, no, don't send thousands of connections to Postgres, trim it down. So that's sort of been our mantra for years. But we've always kind of wondered, why are we slower? What is it about Postgres that makes it not scale, for high number of connections? And Andreas Schroed basically got to, I think, the crux of it. We've been nibbling at this for a couple of years. But one of the things that really kind of got us was the computation of a snapshot. So if you have thousands of idle connections, particularly thousands of idle connections, you have to look at all those connections to see where their transaction IDs are. And when you're doing it over and over again, obviously on a busy system, you get a slowdown.
Is this all about scanning the proc array?
It's really about scanning the proc array, yeah. And frankly, Mark Wong and some others did performance checks. And if you have a busy system where all your connections are active, this is not going to help you at all, right? I think that's what we were actually disappointed when the CTO team did the performance benchmark. We really couldn't see a difference. And Vic Fearing also did work on this. And that's really the issue, that it really benefits if you've got a lot of connections and most of them are idle.
Yeah.
Right. And again, that's where your connection pooler helps, because connection pooler kind of keeps those connections out in the pooler and only allows a certain number to come into the database. So for example, if you had like 100 active connections and 1,000 idle connections, you would probably say, we should have a connection pooler involved here. Whereas I believe with Postgres 14 now, the way we the way the proc array is designed, there's now like an active set and a non-active set. The way the fields that are frequently updated or moved around. What we basically had was a couple cases where we were updating the proc array when we could get by without doing it. And by not updating the proc array as frequently, we're not invalidating the cache of that proc array on multiple CPU dies that we might have in the system. That's really where I think the major work was restructuring it, moving stuff around, and then not having to update the proc arrays often, invalidating the cache, and therefore requiring the other CPU to get a new copy of the cache, which was on the other CPUs. And if you have 4 CPUs, with perhaps 96 cores total, or 125 or 256 cores, and a lot of those are idle and you're invalidating them a lot, that's really slow. And that's where that item really, I think, is going to be a game changer in terms of having a lot of idle connections on some of these bigger systems.
Yeah, so in really simple terms, we're just reducing the amount of data that's stored in the proc array to make it smaller.
Yeah. And preventing it from being updated as frequently. Yeah.
Cool. Thanks for the explanation.
The other one I also love because, again, it's something that's active all the time, and it's something we've been doing that we do in the heap already, and that is, if you're about to insert a row and the table on the page, the AK page is fairly full, we'll go through the page and remove records that are heap only updates that we can just kind of remove. If the record has no unique index entry because it's a heap only tuple, and the page is almost full, we can kind of remove those really quickly and then make space for the new row. And what Peter Gagan now has done is to move that kind of capability into the index, into B-tree particularly. So if you're in a case where a page is almost full, you want to insert a row, the index page is pretty full, he'll go through and kind of remove some of these index entries that are deleted, that really don't need to be there anymore. And he did a great sort of analysis of why this is important. He's like, well, how often does this happen? Probably not that often, right? But what he did, the point he made, so he said most people worry about performance, they worry about things that happen all the time, like snapshot, right? Like the one we just talked about. We're computing that all the time. How often does this happen? Not that often. But the problem is when it happens, and when you can't fit a row on a page, you got to split the page. And when you split the page, there really is no mechanism to merge those pages back together ever, unless you re-index everything. So the beautiful thing he said it's not something that happens a lot, but when it happens, it has long-term negative consequences. So we sort of took this rare thing that you would think would not be a big deal, but in fact is a big deal, because every time it happens, you pay for it by having pages that are not technically as full as they could be. And you may never be adding more rows to these pages, for example, and then you've got 2 pages that are half full, 2/3 full, 1/3 full, and you don't have them. There's no mechanism to merge B-tree pages in a concurrent environment. It's just really hard to do. So I think both of these are kind of interesting because they're not stuff you see a lot, but they have significant value.